So this was a weekly pop quiz related to the multiple choice question, weekly pop quiz 14. You can mention the doubt if you have any doubt in question number 1. Question 1, any doubt? Question 2, any doubt? Question 2. Okay, question 2. In this question, figure in the circuit below, P is a potentiometer of a total resistance of 10 ohm and Q is a fixed resistor of 10 ohm. So the total here, this is 10 ohm resistor and this is also 10 ohm. The battery has an electromotive force EMF of 4 volts with a negligible internal resistance, like what is listed on the battery. Same amount of voltage is being drawn if we neglect the internal resistance. The slider of a potentiometer is moved from X to Y, and a graph of a voltmeter reading is plotted against the slider. So which graph could be obtained? Now, as you see, the voltmeter, what the voltmeter is reading, voltmeter is connected here. So voltmeter is actually in parallel to the battery, the supply. So if the voltage of the supply is 4 volt, what will be the voltage here? The total voltage will also be 4. It is irrespective of the position of the potential, the sliding contact. Like, let's say the sliding contact is at position Y. So if the sliding contact is position Y, so what will happen? Because if you compare the voltmeter is recording the total potential and it is in parallel to the battery. When we have separate connection, so when we have a separate connection, it means that this is another loop or it is in parallel. So whenever two or more components are connected in parallel, irrespective of their resistance, like I may have 3 resistors, 4 resistors, and I connect a supply of a 4. If I connect a supply and a voltmeter, so if this is a 4 volt supply, this will always receive 4 volt. Irrespective of how I change the connection here, I might make it another parallel. I may add another series, but because this is in parallel to the supply, so it will always receive the same voltage. So same thing happen here, that you have a supply. So the voltmeter is actually in parallel to the supply. So if voltmeter is in parallel to the supply, it will record. So the reading on the voltmeter will be same. And if we move the sliding contact, so if we even move the sliding contact to any other position, the reading on the voltmeter will not change because the total voltage which it record, that is same as the voltage of a supply. So that's why option A is the right answer. If let's say the voltmeter was connected here, the voltmeter was connected with one of the component, then the reading of the voltmeter will change because the voltage will divide between them. So the voltmeter will only record what is the voltage across Q. But as the voltmeter is across P and Q, so that it will always record the total voltage, and the total voltage across P and Q, it will divide between them, but the total will always remain 4. That's why the voltmeter always record 4 volts. That's why A will be the valid answer. Question 3, any doubt? Feel free to ask your doubts or mention. Maybe you have many questions as a doubt. You can just mention that question number. Question 3, any doubt? In question 3, 2 ohm and 4 ohm resistors are connected to a cell, which graph shows how the potential V vary with the distance between X and Y. Now, the distance between X and Y, that is a maximum distance. Now, what will happen to the reading of the voltmeter if we take, because the best way, if value is not given, you can take any arbitrary value. So if I say we have a 10-volt supply, because the the ratio of the resistance is 1:2. So if the ratio of the resistance is 1:2, so the ratio of the voltage will also be 1:2. Like the voltage will also divide, one part will be there across this 2 ohm and another part of a will be there. So it means if we divide, so if this is 3.33 volts, this will be 6.66 volts. Now we want to find how the potential vary with the distance between X and Y. So as we start from here, what will be the potential, the voltage? If I say I can take any number, let's say I took 10. So the charges will have 10 joules of energy. When it crosses 2 ohm, it will use some of its energy, and the ratio of the resistance is 1:2. So the ratio of voltage will also be 1:2. So if it's 10, so how much energy will be left? 6.66 joules will be left, and 3.33 volts will be used up here. And then when the charge move from 6.6, like through a 4 ohm resistor, so it has 6.66, what will happen? It will use all of its electrical energy and return back to the supply. So how much voltage will be there? The voltage will be 6.66. But we want to work out the potential, how the voltage vary. So first thing, because the charges, as you can see, the potential or work done per unit charge, so the charges are losing energy. So if it is a 10-volt supply is there, at this point it will have 10, but when the charges crosses, it will have 6.66. And when the charge crosses here, it will have 0 volts. So how much the voltage will decrease? Here it will decrease by 3.33. And how much here the voltage will decrease? It will decrease by 6.66. So when it passes through, when it is at X, it will have a maximum voltage. But when it crosses 2 ohm resistor, it use some of its energy, so the voltage will drop. In this section, because we consider the wires does not have any resistance, practically they have, but for the electric circuits, we assume the wires does not have any resistance, so there is no low voltage drop. And then what will happen? As the charge passes through a 4 ohm resistor, so it will lose its energy, so the potential will also decrease. And the decrease here, when it crosses the 4 ohm resistor, the decrease will be more as compared to when it crosses a 2 ohm resistor. If the two resistors were having the same value, then the potential drop will be same as well. If we have, like, say, this was also 2 ohm. So if two resistors have the same resistance, so in that case, the voltage drop will be same. Let's say this was 10. Here it will have 5, the potential, and here it will have 0. So if we sketch a graph, when it crosses point X, it has a maximum voltage. But then passes through a 2 ohm resistor, the voltage will decrease and it will drop by 5. And then it will be constant because of this section of the wire, it does not change. And then again, it will decrease by 5. So the change, it will change from 10 to 5 and then 5 to 0, same. But because the two resistors were having a different resistance, so the one which is having a low resistance, so less voltage drop here, and the one which is having a high resistance, more voltage drop here. So when the charges move through a circuit, they always have a high potential, and as they move through the components, they lose energy, so the potential will decrease. Is it clear? Question 3. And if this was a 4 ohm first and this is 2 ohms, so in that case, what will happen if it's a 10-volt supply? It will have 10 and here it will have 3.33, and here it will have 0. So in that case, in the beginning, it will drop greater than smaller. Like this will be the drop across the 4 ohm, and this will be the drop across the 2 ohm. But the potential always decrease when the charges move through a circuit or any component. The potential always decrease. Like they lose energy when they are moving. Question 4, any doubt? Question 4. Question 5, any doubt? Question 5. Question 6, any doubt? Question 6, okay. A battery of EMF V, negligible internal resistance, is connected to a 1 kilo ohm resistor. A student attempt to measure the potential difference between the point P and Q using 2 voltmeters, one at a time. The first voltmeter has a resistance of 1 kilo ohm, and the second voltmeter has a resistance of 1 mega ohm. What are the readings? So let's say a student connect a 1 kilo ohm voltmeter here. So he connected a voltmeter which is having a resistance of 1 kilo ohm. Now this is a series circuit. In series circuit, the voltage always divide. So if the total voltage is V and we have the two resistors which are having a same resistance, so the voltage will divide evenly. Like if it was a 10 volt supply, it will have 5 volts here and it will also have 5 volt. If it is a 20 volt supply, it will be 10 volts here and 10 volts here. So same thing, if we have a voltmeter which is having a 1 kilo ohm resistance, so because they have the same resistance, so the voltage will divide evenly. If the total voltage is V, how much voltage will be here? It will be V by 2. And how much voltage will be here? It will be V by 2 as well. So the voltage will divide evenly. So any option V by 2 is correct. So either A can be an answer or B. Now what about if we replace this by a second 1 mega ohm 1 mega ohm voltmeter? Mega means 10 power 6 and kilo means 10 power 3. So when we take a ratio between them, like when I take a ratio between 10 power, so I will divide by the common factor, like the smallest value. So it is like 1000 is to 1. So means if I have a total voltage here, 1000, like the ratio, the comparison is 1000 is to 1. So it means the negligible voltage will be there across this one. Almost all of the voltage will be across the 1 mega ohm, because 1 mega ohm and 1 kilo ohm. So when the voltage will divide, maximum amount of voltage will be here, and a very small amount, very small fraction will be here. So we can say that this voltage here will be approximately, it's not exactly, it will be approximately equals to V here, because here it will be negligible, as a ratio is 1000 is to 1. So that's why we select B as the right answer, that approximately when a 1 mega ohm voltmeter is connected in series with a 1 kilo ohm resistor, almost all of the voltage will drop here and very small amount voltage will drop across the 1 kilo ohm resistor. Because the ratio is 1 is to 1000. Like if I have, say, 1000 volt supply is there, so almost 1000 is here and a very small fraction will be across the 1 kilo ohm resistor. So that's why B will be the right answer. Question 7, any doubt? Question 7. Any doubt in question 7? In question 7, the diagram shows an electric pump for a garden fountain connected by 18-meter cable. A 230 volt main electrical supply is there. The performance of the pump is acceptable if the potential across it is at least 218. So the voltage here will be about 218 volts. The current through it is then 0.83. So the current which is flowing is 0.83 ampere. What is the maximum resistance per meter for each of the two wire? If the pump is connected, if the pump is to perform acceptably. So first, what we have to do, we have to work out the potential. This is a supply is there. So this is actually a series circuit. The if it is a positive and negative, so this will the current, that's how it will flow. Or if this is positive, it's a main supply, so it will be an AC supply, so the current will change. So this is actually a series combination rather than a parallel combination. So we have positive and negative, and the current will flow. We want what is the maximum resistance per meter for each of the two wires. So how we can work out this? We have 230 volt supply and here's 218 volt. So how much will be the potential across? How much will be the potential across them? Because 230 is this and 218 is across this one. So how much will be the potential across each of them? Like the total potential. So 230 you can subtract. So 230 minus 218. So we got the voltage across each of them. And then that voltage, yeah, that is the 12 volts here, and that is the 12 is a total. But out of 12, what will happen? 6 volts will be here and 6 volts will be here. Is it clear how I got 6 volts? Because the total potential is 230. So if 230 is there and 218 volts is here, so remaining with 12, so 6 volts across this one and remaining 6 volts across the other one. And the current through it, 0.83 ampere, it's given here. So first what we will do, we'll find the resistance. How to find the resistance? So resistance is a ratio between voltage and current. So what is the voltage? The voltage is 6. And what is the current? 0.83. So 6 divided by 0.83. What's the answer? 6 divided by 0.83. 7.23. Okay. So the resistance is 7.23 ohm. And the length of this section is 18 meter. The question is, what is the resistance per meter? We want a ratio between resistance and length. So resistance is 7.23. And what about the length? It was 18. So this should be divided by 18. So 7.23 divided by 18, what we'll get? We'll get 0.40 ohm per meter. So it matches with option A. So A will be the right answer. Is it clear? We need the maximum resistance per meter for each of the two. They ask for one. So when they ask for one, this was 230 and this is 218. So the total voltage of a 12 was there. So 6 volt was here and 6 volts was here. And we need for one. So as they ask resistance per meter for each, that's why we solve for one only. So 0.83 current was there and the length for each is 18. So the resistance of one component divided by length, we got the resistance per length for one of the two wires. Question 8, any doubt? Question 8. Question 9, any doubt? Okay. Look, in question 9, just recall the idea of a potentiometer. What is the concept of a potentiometer? Let's say you have a supply which is having a voltage of EY, and there's a wire connected here, and the wire is having, example, a length of AB, and there's another supply is there with a zero sensitive galvanometer. When the galvanometer reading is zero and you move this sliding contact, say this is C. So, and this voltage is example EX. So the concept of a potentiometer, that the ratio of the voltage and the ratio of resistance is same, or we can also say ratio of the length and ratio of the voltage is also same. So I can say, I can write a formula that EY over EX, the ratio for voltage will be same as ratio of resistance. What is the total resistance of this section? So it will be equals to resistance of AB divided by resistance of AC, like this section and this section. Because EY is across whole AB and EX is across only AC. So the ratio of the voltage and the ratio of resistance is same in a potentiometer. Now the same concept we will use. Yeah, you can do other way around. You can also do like EX over EY is equals to RA. You can also write as inverse. You can write as EX over EY is equals to RAC over RAB. So the ratio of the resistance and the ratio of the length is always same when the galvanometer reading is zero. That's the concept of a potentiometer. Like using this, we can work out the unknown voltage or a resistance of the component. So in the question, the EMF of a solar cell is measured on a potentiometer. The potentiometer wire is 100 centimeter long and it is having a resistance of 5 ohm. So the total 100 centimeter, this total is having a resistance of 5 ohm. The power supply has an EMF of 2 volts, like it's written 2.000 volts, so 2 volts. And the solar cell has an EMF of 5 millivolts, 5.00 exponent minus 3 volts. Which resistance R must be used so that the galvanometer reads 0? And the PS, the length is 40 centimeter. So if this length is 40 centimeter, what will the resistance? If 100 centimeter is having a resistance of 5 ohm, so 40 centimeter will have a resistance of X, we cross multiply. So it will be 40 into 5, 200, divide by 100, so it will be 2 ohm. So means resistance of this section of a wire is equals to 2 ohm. So the ratio of the voltage and the ratio of the resistance will always be same in a potentiometer. So if I say, let's say this is the voltage. So this is 2.000 volts is actually 2 divided by the ratio of the resistance of this section. So what is the ratio of the resistance or the voltage? I can say the voltage of a solar cell, which is 5 milli. So I can say it will be 5 into 10 to the power minus 3 equals to the resistance of this section of a wire in which the supply is connected, power supply. So this is 5 ohm and this is R. Because they are connected in series, so I can say it is 5 plus R. As the two components are connected in series, so the resistance will be the sum, the total, divided by the voltage of resistance of this section. So resistance of 40 centimeter wire, that is actually equals to 2. Now we have to solve it for the subject R here. So this 2 will be multiplied. So 2 multiplied by 2, 4. And 4 is divided by 5 into 10 to the power minus 3 is equals to 5 plus R. 4 divided by 5 exponent minus 3. What's the answer? 800. Okay, 800 is equals to 5 plus R. I need R, so 5 will be subtracted there. So 800 minus 5. So we get 795 as the value for R. So which matches with option B. Is it clear, this concept? Any doubt in this? So the ratio of the voltage is equals to ratio of the resistance of the loops. So in this loop, we were having a resistance of 5 in R, and in this loop, we have only a resistance of 2. Question 10, any doubt? Question number 10. Any doubt? Question 10. Okay. Question 11, any doubt? Question 11. Question 12, any doubt? Question 12. In question 12, the battery in a circuit shown has a negligible internal resistance, and R1 and R2 are identical resistors. Which of the following expression give the potential across R1? Look, if we have a total of a 10 volts, and out of 10, if 3.3 volts drop here, how? Because this parallel combination is in series with this resistor. So if this is having 3.3, so how much voltage will be here? So it will be 10 minus 3.3, because the total voltage is 10. And out of 10, in one of the component, the voltage drop across one of the component is 3.3. So how much voltage will be there? Other section of the circuit, which is in series to the first component. So that we just subtract that. So it will be 10 minus 3.3. So this will be 10 minus 3.3. So that's why D will be the right answer. It's the same concept that you have a resistor and you have another resistor. If we say I have a 10 volt supply, if this is having 3.3, how much voltage will be here? It will be 10 minus 3.3. So same thing if we were having two in parallel, and if the voltage here was 3.3, so remaining will be 10 minus 3.3. So it does not make difference. It will make difference to the division when I add more resistors in parallel, but the method remain the same. It's a total minus the voltage across one of the component in series. So remaining will get across the parallel one. Question 13, any doubt? Question 13. Question 14, any doubt? Question 15. The tension, remember one thing, that the speed of a wave is in a string is under root T divided by mu, where mu is a mass per unit length, and mass per unit length depends on the material. If we don't change the material, the mass per unit length will not. It depends on the material as well. Like it also depends on the thickness of the wire as well, but does not depends on length. So there is a tension T in the string with a length L. When the string is displaced, then it releases, it move, and the speed is V. The string has a length 2L. So, and same diameter, we did not change the diameter. So we did not change the diameter, means the density of a material will not change, so the mu will not change. Mu will remain constant. The tension is double. Which of the following expression give the speed? So if this is not changing, the mass per unit length is not changing, V is directly proportional to under root T. And the question, T is length is double, but when we double the length and we keep the same diameter, we did not change the diameter, so the mass per unit length will not change. The mass per unit length will change if we change the diameter as well and the length both together. But in this case, we did not change the diameter. We keep the same diameter and we just double the length. So the mass per unit length of these two wires will remain same. How much matter is there in a unit length, that will remain same. So Mu is not changing. V is directly proportional to under root T. So the tension is double. So if T is double, so what will happen? Because V vary with the root. So if this is multiplied by 2, by what factor it will increase? It will increase by under root 2. As you can see, the power is, if it was V is directly proportional to T, so if the T is double, V will also be doubled. But here V is under root T. So if this is under root T or T is double, what will happen to V? V will increase by root 2. So the V will increase by root 2. So that's why C will be the right answer for this. The student connect the circuit as shown. The resistors are their different length. Any doubt in this? The last question. Question 16, any doubt? No doubt. So this was a MCQs pop quiz 14.